All right, so we already looked at what standard position was. Angle in standard position starts on the positive x-axis. We labeled our quadrants, 1, 2, 3, and 4. We did question 3, and now we're going to learn some special triangles which allow us to do sine, cos, and tan of certain angles without our calculator. The first angle that we need to know is 45 degrees. In order to figure this out without a calculator, we're going to draw a right-angled triangle with one angle that's 45 degrees. What's the other angle? Well, yeah, the other one's 90. What about the one that's not labeled? It's also 45. How did you know that? They all have to add up to 180. Perfect. So if I have a triangle that's a right-angled triangle, and both those angles are 45 degrees, that tells us something about this triangle. Do you know the name of this kind of triangle? Special triangle. But in particular, if you have two angles that are the same, I heard it over there. It's an isosceles triangle. An isosceles triangle has two angles the same. What else does it have the same? It has two sides that are the same. And so the powerful thing about trigonometry is that sine, cosine, and tangent, they stay the same no matter how big or how small a triangle is. If the angle is 45 degrees, sine of 45 degrees is always the same. Tan of 45 degrees is always the same. So if it doesn't matter how big or how small this triangle is, I can pick a length for this side. Okay, what kind of math do you think would be a number that would be easy to do math with? 8.72? 1? Okay, we'll go with 1. You like 8.72? If I make this side 1, then that side is 1. And you can figure out the hypotenuse. A squared plus b squared, 8.72 would have been bad. It's going to be the square root of 2. Okay? Everybody okay with that? 1 squared plus 1 squared equals c squared. 2 equals c squared. So the hypotenuse has to be the square root of 2. Okay. Now that we were able to, did we need our calculator to make that triangle? No. We just picked a side length. We made it 1. And then we did a squared plus b squared equals c squared. Look at that triangle. Can you tell me what tan of 45 degrees is? 1. Why is it 1? Opposite over adjacent. 1 divided by 1 would be 1. If you had picked 2, it'd be 2 divided by 2, still be 1. If you picked 8.72, it'd be 8.72 divided by 8.72. It would still be 1. What's sine of 45 degrees? Well, 0.707 is using your calculator. You're not allowed to use your calculator. Sine is what over what? Opposite, right? Here's 45. Sine would be opposite over hypotenuse. So sine of 45 is 1 over the square root of 2. What do we do when we have square roots on the bottom of our fraction? We multiply, we rationalize the denominator, and so our answer is the square root of 2 over 2. I'd like you to type the square root of 2 over 2 in your calculator. Second square root, if I write the square root of 2 divided by 2, it's equal to 0.707. If you didn't get that, you typed it in wrong. Okay, probably even better if you use the fraction button so you can really see the square root of 2 on the top and 2 on the bottom. You get 0.707. If you type in sine of 45, no, I've got to make sure that my calculator is in degrees. If you type in sine of 45 degrees, you get exactly the same answer. Crazy. So because we could draw this triangle, we can figure out sine of 45 degrees without our calculator. So now this becomes something that's allowed on a non-calculator part of your test. Wasn't so bad. What's cos of 45 degrees? You leave it like this. You leave the square root of 2 over 2 just like that. That's your answer. And cos of 45 will be adjacent over hypotenuse, which is the same thing. So the first angle that you need to know without your calculator is 45 degrees. There's only 3 angles you need to know without your calculator. 45 is one. Okay. The second one. And the third one we'll do at the same time. 30 degrees and 60 degrees. So I'd like you to draw a triangle, a right-angled triangle, and label the bottom right-hand corner with 60 degrees. What does that make the other angle? 30 degrees. What is the name of this triangle? 3 different angles, 3 different sides. Right? We had isosceles is special because it had 2 angles and 2 sides the same. Equilateral is special because it has all angles and all sides the same. Do you remember the name for, they gave a special name for triangles that are like this that aren't special? Sorry. Starts with S. Oh, you're so close. Oh. S. No? One more letter? Scalene. There it is. Okay, now, a scalene is the special name for a triangle that's really not very special. In fact, with this 90 degree, 30 degree, 60 degree triangle, the way it is right now, we can actually not figure out anything. It's kind of useless, right? So this triangle is feeling bad because it's feeling useless, and it's sad, and it comes across another triangle just like it, also feeling sad, and so those 2 triangles start talking to each other, and they're like, are you special? No. And the other triangle says, are you special? No. Well, and so the other triangle, they said, well, they're going to be friends. And these 2 triangles get together, so I'm going to draw the same triangle again with 30 degrees here and 60 degrees there, right beside each other. They get together, and what happens? They make something special. No baby triangles. That's a different class. That's like family studies or something. It makes an equilateral triangle. And what do we know about an equilateral triangle? All the sides are the same. All the angles are the same. They'd all be 60. So something that would be a really nice number to choose, I can pick any number I want, but I'm going to choose this side to be 2. That makes this side 2. That makes the whole bottom 2, but why would I choose 2? Because that would make this part 1 and this part 1. What's the other side of that triangle now? A squared plus b squared equals c squared. You would have 1 squared plus b squared equals 2 squared. And we get the height of this triangle to be the square root of 3. And now we can say what sine, cos, and tan are without our calculator. Check this out. What is sine of 30 degrees? Look on your triangle. Where's the 30 degrees? What's your opposite side? What's opposite of the 30? 1. What's the hypotenuse? 2. Type it into your calculator. Does sine of 30 degrees give you 0.5? Yeah. All the time. Ever. Forever. Cos of 30 degrees. Cos of 30 degrees is adjacent. What's adjacent to 30? Root 3 over hypotenuse. What's the hypotenuse? 2. And tan of 30 degrees, we look at our triangle. Tan is opposite, which is 1, over adjacent, which is square root of 3. What do we have to do when we have square root on the bottom? We have to rationalize. And so tan of 30 degrees is the square root of 3 over 3. And the reason we have 30 degrees and 60 degrees at the same time is because we can also do sine of 60 degrees. There's my 60 degrees. What's my opposite? Square root of 3. What's my hypotenuse? 2. Cos of 60 degrees, 1/2, and tan of 60 degrees, root 3 over 1. How did I get tan of 60? Or which one? Sine of 60? Where's my 60 degrees? There it is. Sine is opposite. Opposite side is root 3 over hypotenuse. 2. Root 3 over 2. Cos of 60 degrees. Adjacent side, 1 over hypotenuse, 2. Tan of 60 degrees, opposite, root 3 over adjacent, 1. So if you can draw the triangle, you can find them all. Or you can decide just to memorize them, but sometimes since they're so similar, you're going to mix them up. All right, so I'd like you to try questions 5 and 6.